have sand falling off a conveyor belt and onto a conical pile. It's falling at a rate of 10 cubic feet per minute. This rate of 10 cubic feet per minute is the rate of change of the volume. We know this because as the sand falls into a pile, the entire pile gets larger, the height and the circular base of the pile. Another giveaway is the units, which are cubic feet per minute. When a unit is cubed, it's most likely referring to volume. Also given that the diameter of the base of the cone is 3 times the altitude, or height of the cone. And given that information, it's our job to figure out the rate at which the height of the pile is changing when the pile is 15 feet high. So let's set up some variables. H is height in feet, D is diameter in feet, which is also equal to 3 times the height, V is volume in cubic feet, and dV dt is the volume's rate of change in cubic feet per minute, which is given to be 10 cubic feet per minute. We're looking for dH dt, or the rate at which the height of the pile is changing in feet per minute when the pile is 15 feet high. So let's set up an equation to connect these variables using the volume formula of a cone, which is volume equals pi times radius squared times height times 1/3. We're going to replace the radius squared with half of the diameter squared because radius is equal to half of diameter. So we end up with the equation volume equals pi times 3/4 times h cubed. Since we're looking for rates of change, we're going to differentiate both sides of the equation with respect to time, which will allow us to find the instantaneous rate of change of the pile's height when the pile is 15 feet tall. We can substitute 10 for dV dt because we're given that the rate of change of the volume is 10 cubic feet per minute. And now we can finally substitute 15 for h. The height of 15 is not a constant since the height of the pile is constantly changing over time. Because of this, we can only plug in 15 after we've differentiated the equation. Now that all that scary calculus is over, it's time to simply solve for dH dt. Your final answer will be 8 over 405 times pi feet per minute.